Okay, 5.6, transformations of the sine curve, putting it all together. Dun, dun, dun. So we have this equation now, and we're going to do all of it at once. So we have this a value here. This a value is going to give us vertical stretches and compressions. That's what it's going to do. And that's going to change your amplitude. So this is going to change the amplitude. How far up I have to go in the y-axis and how far down. Now it does something else. If this a is negative, less than 0, so if it's negative, then we have a reflection in the horizontal axis. And, as we know from our previous work, stretches, compressions, and reflections must happen first. Then we have the h. Now look at the h. I call this inside the side function. It's inside the argument of sine, inside those brackets. So that's going to be a horizontal shift, left or right. It's also called a phase shift if you really want to be kind of, what's the word? Classy. I really think it's classy. You're gonna call it a phase shift. And the k on the outside here, see how it's outside the sine function? So I call that outside the sine function. That's what I do. It's outside the brackets. It's outside the sine function. And that's going to be your vertical shifts up and down. Okay, so we got a bunch of stuff going on here. Let's take a look at a question that's got a bunch of stuff going on here. Now, I'm going to do my own thing. I'm not going to read these words. I'm not going to do the real question. I'm going to do what it says here. I'm going to sketch this. Now, I'm going to do this my way. Frank Sinatra, he's had a song that said, I'm doing it my way. And I'm going to do this my way. Now, if I was to show you, list out all the transformations that are going on here, you would see that we have a vertical stretch by a multiple of 2. That would be the first transformation that you see here. Now, there are others. There is a horizontal shift to the right, or if we really want to be special, we could call it a phase shift. P dot S dot will stand for phase shift. So it's a phase shift of 30 degrees to the right, and you have a vertical shift, VS, vertical shift of 3 units up. And those are going to happen second. So, now, the way I'm going to think about this is I'm going to graph 2 graphs to get my one graph. The first graph I'm going to graph is going to deal with just the vertical stretch. So that is going to have a vertical stretch of 2, which means instead of going up to 1, it's got to go up to 2. And instead of going down to -1, it's got to go down to -2. Okie dokie. And I'm going to come out here and I'm going to go 90, 180, 270, 360. And I'm going to sketch the sine curve with just a vertical stretch of 2. So it would look like this. That's what the equation would look like, and it would look like this. Whee! Now, make it nice and curvy. Start at the top, come down. Start at the top, come down. Start here, come down, and then come up. Look at that, nice and curvy. And that is this curve. Not the curve I was looking for, but it's that curve. What I'm going to do with this curve now is I'm going to do a phase shift of 30 degrees to the right, and I'm going to move it up 3 units. Now, for me to move it up 3 units, I'm in a bit of a pickle here because it's got to be able to move up 3 units. And I've gone outside my graph here. So that's 1, there's 2. That would be 3. That would be approximately 4. And that would be approximately 5. And I'm going to have to go up to 5 because notice I'm at 2 here. And I have to go up 3 more. And that, ladies and gentlemen, is 5. 2 plus 3 is 5. All right. Now, and I also have to do a phase shift of 30 degrees. So I'm going to come out here 30, 60, 90. Isn't that convenient? So this is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, and 390. So, which way am I going? I'm going to the right. So this point is going to move 30 degrees to the right, which is 1 hash mark. And it's going to go up 3 units. Now, not 3 hash marks, but 3 units. So it's going to go up 1, 2, 3. And that point has moved to here. Now, this point, it's going to move 30 degrees over to the right. And it's going to go up 1, 2, and 3 units. This one, over 30, up 1, up 2, up 3. This one, over 30, up 1, up 2, up 3. This one, over 30, up 1, up 2, up 3. You'll notice that the horizontal axis has moved up 3. So it used to be here, but it has moved up 3. And my new curve is zoom, 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 and zoom. And this is, in fact, the curve. Now remember, I used this curve to get this curve, so it has a vertical stretch of 2. And it has a horizontal or a phase shift to the right of 30 degrees, and it is moved vertically up 3. And that, ladies and gentlemen, is my answer. Now, you can pause the video and make your graphs just as pretty as mine. And then when you come back, we're going to take a look at the point notation for this. So, the original curve is x comma sine x. And we want that to go to a new curve, x comma, well, hold on. Is it x comma? Look what's in here. It has to be moved to the right 30. So it has to be moved this way. So all my x values have 30 degrees added to them. That's how we're going to move to the right 30. Oh, okay. And there's a vertical stretch of 2, which means that the sine x has got to be multiplied by 2. And there's a vertical shift up 3. So that means that the sine x also has to be up 3. Now that's a little bit more complicated. Nobody said that this was going to be straightforward. We may have to think about this for a minute. So then what you could do is you can come up with your critical points for the sine curve, which are as follows. 270, negative 1. 360, 0. So those are my critical points for the sine curve. They will come over, so x plus 30, x is 0, so it's going to be 30, because 0 plus 30 is 30. Sine x is 0, so 0 times 2 is 0, plus 3 is 3. 90 plus 30, 120. 1 is sine x. 1 times 2 is 2, plus 3 is 5. 180 plus 30 is 210. 0 for sine x, 2 times 0 is 0, plus 3, 3. 270, 300. Negative 1 is sine x. So negative 1 plus 2, oh sorry, negative 1 times 2 is negative 2, plus 3 is 1. And then it's going to be 390. 0 for sine x times 2 is 0 plus 3. So these points should be the points on my final graph. Let's check. 30 up to 3. Oh my goodness, there it is. 90, that would be another 30, so 120 up to 5. This is 120 comma 5. This one here, hold on, this will be 80 plus 30, so it's 210, and it's 0. Uh-oh. It's not 0, it's 3. What am I thinking? Fooled you. So it's 3. This one, 270 over to 300, up to 1, so this is 300, comma 1. There it is. And 390, comma 3. 390, comma 3. Oh, you know what, ladies and gentlemen? Life is grand. Well, there you go. That's how that works. I'm going to stop the video here and do the next one.